In a daring announcement, scientists claim to have discovered a new planet unlike anything known. NASA, renowned for its groundbreaking findings, has revealed that this planet is fascinating not only because of its size and location, but also because it displays light that appears to be artificial. Are we on the verge of uncovering secrets that could transform our understanding of the universe? Could this finding indicate the existence of life on other planets? By exploring NASA's amazing discoveries, we may soon learn the truth about these extraordinary lights. In 2007, NASA launched the Dawn spacecraft with a mission to explore some of the most intriguing objects in our solar system. Equipped with 3 ion engines, Dawn embarked on a journey that began with a 14-month study of Vesta, the second-largest asteroid in the belt. Dawn sent back detailed images and data, revealing Vesta's complex surface and diverse geological history. After completing its mission at Vesta, Dawn began the second, and perhaps most exciting part of its journey, a detailed study of the dwarf planet Ceres. Thanks to its ion engines, Dawn was able to leave Vesta's orbit and head toward Ceres, something that traditional chemical propulsion would not have allowed. These engines provided a gentle thrust that enabled Dawn to travel great distances and enter a stable orbit around Ceres. Discovered in 1801 by Italian astronomer Giuseppe Piazzi, Ceres is the largest object in the asteroid belt between Mars and Jupiter. For many years, it was considered the smallest dwarf planet in our solar system until its reclassification in 2006. With a diameter of approximately 950 kilometers, Ceres is both the largest and most massive body in the asteroid belt, and one of the most fascinating because of its unique characteristics. Scientists eagerly awaited the first detailed images of this mysterious world, which revealed bright spots scattered across its surface, especially in a large crater known as a crater. These bright spots sparked immediate interest and speculation in the scientific community. Before dawn, the best image we had of Ceres was a blurry, low-resolution photo taken by the Hubble Space Telescope. Very little was known about this dwarf planet, and the prospect of finally getting a close-up promised great discoveries. The Dawn mission sought to improve our understanding of the formation of the solar system and the role of water in shaping planetary bodies. The bright spots on Ceres, also observed on other asteroids, could be composed of highly reflective material, possibly salts left behind by sublimated water. The discovery suggested the possibility of cryovolcanism on Ceres, a process where volcanoes erupt liquid water or brine instead of molten rock. But what exactly are these mysterious lights? And what do they reveal about the nature of Ceres? Could they be evidence of ongoing geological activity, or something even more extraordinary? Ceres stands out from other bodies in the asteroid belt because of its size, mass, composition, and potential to contain water and ice. Unlike typically rocky asteroids, Ceres has a more comet-like composition, suggesting it could reveal more secrets about the early solar system. After 2 years in transit, the Dawn spacecraft finally began its approach to Ceres in early 2015, marking an important milestone as it prepared to provide the first close-up views of the largest object in the asteroid belt. As dawn drew closer, images of Ceres became increasingly detailed, revealing a world previously shrouded in mystery. The first images showed a cratered surface indicative of a long history of impacts. What caught the attention of scientists and space enthusiasts were the mysterious bright spots in the dark, rocky terrain. As the resolution of the images increased, the scientific community formulated theories about the nature of these bright spots. Were they patches of ice reflecting sunlight? Or could they be something even more exotic? Speculations ranged from mineral deposits to potential signs of cryovolcanic activity. To everyone's surprise, closer inspection revealed that the brightest spot was not a single entity, but a cluster of several distinct spots. The most widely accepted hypothesis was that these were deposits of salt left by the sublimation of water. This suggested that Ceres had, or still has, some form of geological activity capable of bringing water or brine to the surface, where they quickly evaporate, leaving bright reflective residues. These findings challenged existing notions about Ceres, painting a picture of a more dynamic and complex world than previously imagined. The possibility of groundwater or brine pockets could have profound implications for our understanding of the potential for life in our solar system. Ceres is an intriguing dwarf planet often described as an icy world with a rocky but porous surface. Different from most bolides, which are composed primarily of rocks and metals, Ceres is notable for its unique composition. Its surface is a mixture of water, ice, and hydrated minerals, including clays and carbonates, which give it a less dense structure than its rocky neighbors. This composition suggests that Ceres contains a significant amount of water. Its surface layer is rocky but porous, with ice and other volatiles trapped, making it more like a comet than a typical asteroid. The dwarf planet is believed to have a distinct interior composed of a muddy mantle and a core rich in water ice, which accounts for approximately 50% of Ceres' total volume. The mantle is probably a mixture of rock and brine surrounding a core possibly composed of denser materials such as silicates. The presence of a significant amount of water ice suggests that Ceres may have hosted liquid water in the past, especially if its core was heated by radioactive decay early in its history. This internal structure distinguishes Ceres from its neighboring asteroids and raises intriguing questions about its potential for geological activity and the role of water in its evolution. But that's not all. The discovery of ammonia clays on Ceres suggests that this dwarf planet may have formed in a cooler part of the solar system and then migrated inward. The presence of ammonia may lower the freezing point of water, supporting the existence of surface brines. These insights into the composition and history of Ceres not only enhance our understanding of this fascinating dwarf planet, but also provide valuable clues about the processes governing the formation and evolution of icy bodies throughout the solar system. Cryovolcanism is a fascinating and relatively rare geological process, especially compared to the more familiar volcanic activities we see on Earth. Unlike traditional volcanoes that erupt molten rock, cryovolcanoes, also known as ice volcanoes, expel material such as water, ammonia, or methane. These substances can exist as liquids or gases in extreme cold environments where cryovolcanoes on Ceres are found. Cryovolcanoes on Ceres function by allowing water laden with dissolved salt to reach the surface. When the salt water makes contact with a vacuum of space, it rapidly sublimates, going directly from a solid or liquid state to gas. This leaves behind glowing reflective deposits of salt. These salt residues form the mysterious bright spots observed on the surface of Ceres. The most famous of these bright spots is in a crater called a crater, known for its highly reflective region called faculae. This area has garnered much attention because of its high reflectivity and periodic hazes observed by the Dawn spacecraft. These hazes are believed to be caused by water sublimation, suggesting that cryovolcanic activity may still be occurring, or have occurred relatively recently, on Ceres. In addition to a crater, Ceres hosts several other bright spots, each with its own unique characteristics. These spots are not confined to a single area, but are scattered across the surface of the dwarf planet, indicating that cryovolcanism may be a widespread phenomenon on Ceres. The presence of these bright spots highlights the dynamic and active nature of Ceres, challenging previous assumptions that it was a geologically inactive world. As the Dawn spacecraft provided more detailed images of Ceres, a wide variety of surface features began to emerge. Ceres' surface is dotted with craters, each telling the story of the dwarf planet's history. As Dawn continued to orbit Ceres, scientists gained even deeper insights into the planet's surface and internal processes. If you like the video, remember to like and subscribe.